Hello, everybody. This is Sunday. It's September 19th, and here we are headed into the fourth week of our online astronomy course. This week, we're having the second module explaining the science behind astronomy. In last week's module, we looked at Newton's laws of motion and gravity. And this week, we're learning how astronomers use the light given off by celestial objects in order to learn more about those objects. And one of the best tools astronomers have is the breaking up of light into its component colors, into its rainbow spectrum, like the rainbow that you see behind me. Now, Isaac Newton, who you've heard about a lot last week, Isaac Newton was involved in this also because he was the first person to ever break white sunlight into all the colors of the rainbow, that continuous spectrum. Now, it turns out that if you really look at what happens to the light that is passed through a spectrum, what happens to the sunlight, you'll see that that rainbow spectrum has a lot of dark lines in it, or light of certain wavelengths has been absorbed. And that tells astronomers what is going on in the sun, what the sun is made of, because each element, if you heat it up until that gas glows, has its own unique characteristic set of spectral lines. And overall, the continuous spectrum of the sun is called black body radiation. And every object with a temperature above absolute zero gives off black body radiation. You have a temperature above absolute zero, and so you're giving off black body radiation. And you can feel it. It's not visible radiation. If you turn out the lights in the room, you're in the dark and you're not glowing. But if I had an infrared camera, I could see you. And you can feel that infrared light if you just take your hand and put it in front of your forehead, but not quite touching, and move it close. And you'll feel that heat coming off your forehead. That is the infrared radiation that your body is giving off because your body is behaving like a black body. A black body is any object that absorbs all the light that hits it and then re-radiates that light out again in a characteristic spectrum called the black body spectrum. So you'll be learning about that. I've made 3 videos to show you, first of all, a black body spectrum and how the spectrum depends upon its object's temperature. And you'll find out that's why some stars are blue, some stars are red. The blue stars are hotter and the red stars are cooler. You'll also see about the dark absorption lines that happen. Those are created when the continuous spectrum of light passes through a cool gas, and that gas can absorb some of the wavelengths of the light. So you get these dark lines in the object spectrum. Also, a hot glowing gas can also emit bright emission lines, and there's a video on that. And you'll see how astronomers use this to gain a lot of information about the stars. We know what the stars are made of because we study their spectra. We know how fast stars are moving because those spectral lines can be Doppler shifted. If you've ever sat at a railroad crossing and you're just sitting there and waiting for a train to go by, and the train blows its whistle as it goes by, you know that whistle sounds different as it goes by. And so if it starts over here and it's approaching you, its whistle or horn sounds higher. And as it passes you, it goes lower. So it sounds like, let's hear that again. Same thing happens with light. The frequency of light, the wavelength of the light changes. And that's how we know how fast stars are moving and how fast galaxies are moving. And that will come in much later in the course when we talk about the expanding universe. Now, this is the 4th module of the course. And that means that this week is the end of the first part of the course. And so the week after next, not this coming week, but the week after that, you'll be having your first exam. You take that exam at home. You will take it using Canvas, and the exam is open book. You can also refer to your the homework that you've been doing when you're taking the exam. And when you're done, you can find out which questions you missed. And if you want to, you can take it again. And if you do that, if you take it twice, I'll give you the average of your 2 scores. So it's up to you. So some really important stuff, because astronomers are the experts at looking at light. So I'll also tell you some things that are going to be coming up in the sky. And so I'm going to pull up Stellarium here. Nothing really spectacular this week, but still on this Monday is the full moon. And in fact, this is the harvest moon. The harvest moon is the full moon that takes place closest to the harvest. And it's either the very end of summer or the very beginning of autumn. And this year, fall starts on Wednesday. That is the fall equinox, the autumnal equinox. And that starts at 1:20 p.m. That's Utah time, Mountain Daylight Time. 1:20 p.m. on Wednesday is the instant when fall begins. And so this new moon happens before that, so it's the last full moon of the summer. Now I've put up some of the constellations because some of these might be unfamiliar to you. And for instance, here is Aquarius, the water bearer. And down here is Cetus, the whale, Pisces, the fish. It's always fun to put up the figures for those to see. Aquarius, the water bearer, Cetus, the whale. Sort of a weird looking whale, isn't it? And then Pisces, the fish. And Pisces also goes up here too. So this is one of the pair of fishes that make up Pisces. Also, if you look over to the side, you can see over here is Jupiter, and a little bit further over is Saturn. And I'll just move that over so you can see Saturn peeking out. So that's what's in the sky this week. Full moon tomorrow, and full moon, the harvest moon, and then the first day of autumn, first day of fall on Wednesday. So I hope you enjoyed learning about light. And as always, if you have any questions, any concerns, please contact me through the Canvas email. I'll be happy to answer those questions. Email questions, if you'd like. I can set up a Zoom meeting to talk to people. I've done that already for people. I enjoy doing it. And if you'd like, I have an office at Weber State, and you're welcome to come in and see me in person. So have a good week, and I'll look forward to seeing you next time. So until then, bye-bye.